Hey! Happy July, everybody. Welcome to week 2 of CS410J Advanced Java Programming here at Portland State. Thanks for coming out tonight. We got a lot of people here still. This is good. Probably some more will trickle in as we continue on. Let's see here. I want to start out tonight getting some feedback from you guys on what's happened over the last week and get any questions or concerns or things that I want to know about. And then we'll cover some more of the administrative of the class. We've got 2 handouts, actually e-handouts. Yeah, I'm actually going to give you paper tonight. Talking about how to document your projects and how to submit your projects, which are very important things because your first project is due next week. Then we'll talk about the second project. And then we'll do some more live coding on that student project that we started last week. And Sean, the grader, and I are going to do a little bit of pair programming for you guys so you can see what that's like. And that'll be it. So to start out with, how was your week? Yeah, no kidding. Okay. But I know Java's hot, but okay. So how's everybody feeling about their ability to start in on the project? Has everybody been able to start get up and running with Java? Yeah, for the most part. Okay. Maven, good. Okay. So have you executed one of the archetypes yet? Either the Cohens or the Project One? Saw some good questions on the Google Plus community. Please be sure to subscribe to the Google Plus community. That's how you're going to find out about things like, oh yeah, class starts at 6 o'clock tonight. Let's see here. What else? Has everybody been able to run the survey program? Yeah, and if you haven't, that's on the syllabus. Please make sure you can do that. That'll give me some important information about you, and also make sure that your CS department Unix or Linux account is configured properly. So you can test out the projects before you submit them. Let's see here. What other questions do you have that we should talk about before we get started tonight? Nothing really? It was so self-explanatory. You kids have the Google these days. Yeah, what's up?
Were you going to re-upload the pre-class videos?
Yes, I did. And they should be... Oh, did I... You know what? I might not... No, I think I updated these. Let's try this one.
Oh, look!
That's
the
loud.
Test
That's
passes! Loud. It's time for me to go
so sorry.
To the green phase.
So
I am now green. And in the green phase...
So I think the videos are loud enough. I did upload a new batch. So the ones that are linked, I think these are both... Yeah, so I think these are the loud ones now, and I've also linked to them here on the homepage. Is that what you're asking?
No, the ones under Javadoc, the podcast, is the first 3.
Oh, the podcasts. No, sorry. Yeah, that's all. Yeah, bad audio from 2009. What I should really do is just redo those. But no, I wasn't planning on upping the volume on those. Sorry about that. Yeah. Thanks for listening to the podcast, though.
No, I mean that they're not available.
They're not available. Oh, I believe that. Yeah, there I am. With complete...
Hi, I'm David Whitlock.
Oh God, I'm lame. So that one's there. Yeah, it's 2009. Yeah.
Welcome back to the in-depth review of the...
Okay, so it seemed to be working for me. What's the music now?
Welcome back to the in-depth review.
Yes, all the
of
free
Java
music that
programming.
comes with GarageBand on the Mac. So I think those are okay. Were you having problems accessing them? Okay. Let me know. Okay. Well, that was an embarrassing flash from the past. Okay. Anything else before we get started? Okay. Sounds good. So, week 2. Oh, and the quiz. Hope everybody did the quiz. Yep, everybody's able to access D to L and all that good stuff. Okay.
40 people turned it in.
40 people! Right on. They're 10 are slackers. And probably aren't registered for the course anymore. So. Sorry, what? I don't know how many are enrolled right now, but it was the max was 50, and at one point we were registered for 50. Probably a couple people have since departed. Okay, so Sounds like everybody got started on their projects. That's really good. There are a couple more things that you need to know about, though. Okay, so documenting your code. So in this class, we write a bunch of code, and also I want to make sure that your code is well documented. And documentation is a really essential part of developing software, making sure that you can explain something in English just as well as you can explain it in code. And usually when you've taken the time to document your code, it means that your design is well thought out and that it's easier for other people to work with your code also. And so there are two mechanisms that we use in this class to document your code. The first one is called a plan of attack, or a POA. I think a number of you noticed that in the first assignment. There's this thing called, 1 point for the POA. Wait, that counts towards my grade. What is that? Well, here's what it is. So starting with your project 1, you'll be required to submit a plan of attack, a POA, for every project. And so what a POA is it's a little design document. And by little, I mean like a couple of paragraphs, no more. And it describes how you will implement your project. So sort of a description of here's what it is I'm going to do, and each project has a POA, and it's worth 1 point of your project grade. The POA should be submitted to me at this email address with the letters POA in the subject, and I use email filters and stuff to put all those in a folder, and then I'll go and grade them at my leisure. So it means if you've got an important question for me, don't put the letters POA in the subject because it'll get filed off and everyone will see it for a long time. It's also important, please, when you submit your POA via email, please send it just as text. Just type an email. Don't attach a Word document or a PDF or an image or a WordPerfect 5.1 file. Whatever it is that you're using, don't do that. Just text. Please, that'll make everybody's lives easier. Well, no, it'll make my life easier. Anyway, let's see here. And of course, the reason that I ask you to do this plan of attack is to encourage you, actually, just to force you to think and then write about your project before doing it. And also, the POA is due 72 hours before the project is due. That's Sunday night at 6 p.m. And so then, this way, well, if you wait until the last minute to start your project, you've already lost 1 point because I don't accept late POAs. So, any questions on the plan of attack? No? Yes?
Should it contain POA? Should it say project 1 POA in the subject?
Just the word POA. So POA for project 1 is fine. I'll figure it out based on either the contents of the POA, but yeah, if you want to put the project name in it, that would help also. Yeah. So that would be really good. Okay. Questions on that? Good. Yeah. The other documentation that I'd like you to write for your projects is in Javadoc comments and something called the README. Writing good code is important, and actually writing method names that make a lot of sense, variable names that are descriptive is very important. But I want you to take advantage of Javadoc. So Javadoc is a style of documentation comment in the Java language, and basically what you do is you can put a special comment that starts with /** and ends with */ that precede program elements like classes and fields and methods. And what these documentation comments do is they describe that field, that class, that method. You can read all about it here off on the Oracle website. You have these documentation comments in here, and then there is a tool called Javadoc that will parse your source code and will extract those documentation comments. And, I think we saw a little bit of it last time. It'll generate pretty HTML documentation by default, but you can also write something called a doclet, which I've done, which will take those comments and just spit it out as a text file. One of the tests that I do for your projects is that I extract all the documentation and I print it out, and some portion of your grade will be dependent on the amount of documentation, the amount and the quality of the documentation that you have. So, for instance, if you have a Javadoc comment for a method, You should describe the functionality of that method, and you should use the Javadoc tags, which here again you can learn about, or I think they're also in some of the lectures, for things like describing parameters, the return value, the throws, etc., etc. Any questions on the Javadoc?
So is that as a separate document it ends up being?
No, it's actually embedded in your source code. So let's see here. Do I have an example of one? Well, here's one right here. Right, so here is a Javadoc comment, and you can tell because it starts with /**. And this is the Javadoc comment for this entire class. And so then, yep, I would expect your code to have something like this. Here again, a sentence or two, doesn't need to be a novel, that describes what it is that your class does, what it is that the method does. And then you can have things like, for this method here, creates a new student. I would put that in a code tag. Oops. With the given name, and then the name param is the name of the student, and returned the new student. In some respects, it's probably overkill. Duh, you can sort of figure this out. Probably in the real world, you wouldn't do this. But this is one of those things where I want you to learn how to use Javadoc, and this is how I assess that. So yep, I expect methods to have that. And so this documentation is embedded in the code, which is nice because then your documentation is right next to the code, so it's easy to verify that everything is accurate and consistent. And then I run a tool that will extract the comments and write it out to the log file, just like the output of your program. Sean will assess the quality of that.
So should we use the open close code tags, things like that?
Is it important? No. I mean, I think what's yeah, and it is more about, yes, saying what it is that your code does in English. I encourage you to learn about things like, the code and how to use URLs and things like that, but that's very secondary to the description, the descriptive nature of your documentation. Yeah. Yeah. Actually, well, let me show you maybe perhaps a better example. Okay, so I'm going to open up this big old project that has all of the new window for the source code for my class and for the examples and everything. And one of the examples is main Java lang. Nope. Oh, that's JU. Sorry. Lang Javadoc. Okay, so here's a class called Javadoc. It's kind of an example class. So here's a comment here with this class demonstrates Javadoc, and here's the author tag and the version tag. It has one method called invert, and here's the description, and then it has a description of the parameter, what it returns, and then what it throws. And then you can run Javadoc, Javadoc tool, and it'll generate something that looks like all this for all the class. And so then, and this is what the standard Java API documentation looks like also, right? And here is the Javadoc. So again, back to the source code. This class demonstrates Javadoc comments, authored by me, version 1.0. So it generates HTML with that description, the version, and the author. Here's that invert method. So here's the signature. There's a description of the parameters. Here's what it throws. I've configured it to go and link off to the official API documentation, so you can do that too. So this is Oracle's Java documentation, stuff like that. So yeah, and you can do this from Maven. Let me get out of this. Just close that window. Sorry. Oh, never mind. student. So here's like the other project, the student project. It doesn't have as interesting Javadoc. But if you just say Maven Javadoc, so the Maven Javadoc plugin, the Javadoc goal of that. Oh, what was that big warning? Okay. Had like some warning there. Oh, no @param for args. Well, that was nice of it. It creates in the target directory, I think in site, because it's all about building a site for you. Ooh, look at all that good stuff. API docs, there we go, index.html. That's it. It's got one class, it's student. Well, I don't have links off to other things. I could configure that if I really wanted to. But yeah, here's the Javadoc for that. Oh, it's interesting. It sort of says it overrides the says method in class human. So anyway, so that's all that. That's all. Oh, I could have just done this. Okay. Yeah, this has pretty good API documentation also. So that's how Javadoc works. Okay. In addition to Javadocs, I strongly encourage you, because I doubt we're going to grade you on it, but since you're learning about Java, I highly recommend that you check out the standard Java coding conventions. Sun, back when Sun controlled Java, and now Oracle does, had their set of coding conventions. Google has come out with a style guide for Java, which builds upon that. It's really good. And this will help you write idiomatic Java, or at least your Java will look like other people's Java, and therefore you'll be able to read other people's Java more easily. Other people will be able to read your Java more easily. And this talks about things like sort of where to put keywords and where to put parens and braces and stuff like that. Again, we're not going to try to enforce that, but since you're learning the language, or some of you might be quite new to the language, I recommend that you read this, and it'll give you an idea of how to write Java that looks familiar to people. Okay. Also, as if you weren't writing enough documentation, each project has a -readme option. And what it does is it prints a brief, concise, and nicely formatted textual description of what your project does. Here again, putting your project into words so that someone knows what your project should do. The README should include your name as well as which assignment, and should be more than just command line usage. So this should be a little description of what it is that your program actually does. Or rather, if your command line usage does include a description of what the program does, yeah, it's okay to do that, but it shouldn't just be like, here's what all the commands mean, here's what all the options mean. Let's see here. Oh, and it's important to note that when -readme is specified, your program shouldn't do any work. So don't bother doing error checking or checking other things with the command line. When you see -readme, just print the readme and exit. And that's that. So, any questions on the documentation? So several things: plan of attack, Javadoc, style, and README. Good stuff? Yeah.
So we won't be submitting our tests, will we?
No, you don't submit your tests, which is something that, I don't know, I gotta do something about that someday, because I mean, if you guys are writing tests, boy, I'd like to see it, and that'd be good. And I think it's more of a matter of how do we assess the tests. Other than we can run them and look, they all pass. Good, that should happen anyway, but it's really about, do I want to require some minimum quality of tests? And I don't know how to do that exactly. Like I do code coverage, but it's like, it's lame. Yeah, so I need to figure that out. If anybody has any good ideas, I'd be happy to hear them.
So for the most part, we don't need to worry about documenting tests aside from our purposes.
Right, so you don't need to document the tests, because I'll never know. So if a tree falls in the forest and your professor doesn't grade it, doesn't make a noise, do you care? Is this going to be on the final? Yeah, okay. Okay, so that was documenting. Okay, submitting. So you've gone and you did your POA on Sunday night, and then you implement your code using test-driven development and writing Javadocs all the way, and you feel really solid about it. You feel that your program is really well tested, and now it's time to submit it. So many years ago, I wrote a program that uses the Java Mail API, which is a Java API for sending and receiving email, to submit the source code for for your projects to the grader. So there's like 2 email accounts for this class. There's my personal email account. There's also a grader email account, which is what you use to submit things to, except for the POA, and that comes to me. Anyway. And the name of this program is edu.pdx.cs410j grader submit. And you tell it some information about the files that you want to submit, about yourself, the project, and the files that you want to submit. And it verifies a couple of things and then puts all your source code in a jar file and emails it off to the TA. This program, much like the survey program, works best if run from the CS machines. I think you can configure it to use a different SMTP server, but since I'm going to grade it on the CS machines, it makes sense for you to get your source code on the CS machines, test it out a little bit, make sure everything still works, and then submit it all from there. So this is the way it looks on the command line, a lot like the survey program. And here are the command line arguments that it expects. The name of the project, and new this year, I validate the name of the project. So it must be something like capital P, Project 1, Project 2, etc. If you get it wrong, I'm almost certain that it tells you what the valid options are. So the name of the project, who you are, and so that's like your full name, and then your login ID, your email address, because you get a copy of the, you get a copy or at least a confirmation email that was submitted, and then 1 or more source files that you want to submit. I added over the winter. I added a check to the submit program. It won't let you submit fewer than 3, I think, files. One of the things that one of the mistakes that students have done in the past is that, okay, I got 3 files to submit. I'll run the submit program 3 times, and then I get 3 jars. I got to reconcile them, and that doesn't scale when there are 40 of you. So I put in some time over the winter to make the submit program a little smarter. And I'm telling you this is because it hasn't been tested yet. So I tested it myself. I think I got everything right, but you guys might run into problems. Let me know if you run into problems. Because, well, my code's not perfect. Far from it. Anyway, so I have an example here. Oh, and there are a couple of options that you may or may not use, including you can add a comment if you run into some weird problems, or turn on verbose mode. But this has worked pretty well for people in the past. So let's say, this is probably a bad example because I'm only submitting 1 file. If I'm just, oops, whoa, what was that? Just launching email. Stop you. No, no, no. Oh no, I quit Chrome too. Caught on tape also. Oh, so embarrassing. I'll edit this out and put some disco music over it. Did I launch Chrome? Yes. Top hit. Casey Kasem. Okay. Where was I? Okay, yes. The example. So here, this isn't exactly conformed to Maven. It's just kind of an old example back before I used Maven. But anyway, so for instance, I could cd into the directory that has all my source code. We're on a big old command line like this with the submit program / is line continuation. So the name of the project is project 0, my name, my ID, my email address. Don't click on that, and an optional comment. And then the files that I want to submit. In your case, it would be like, project 1, and then phone bill and phone call. So those are the 3 that you guys are writing. What you'll get is sort of a confirmation. It'll say, hey, here's all the files that I want to submit, and ask you, do you really want to submit them? Say yes. And what will happen, it'll take all those, create a temporary jar file, and then email that jar file off to the grader, and you'll receive a receipt telling you that, yep, I received your grades. Let's see here. It's okay if you submit multiple times. before the deadline. I know that yep, you think everything's all set, and then you wake up in a cold sweat. And you're like, oh, I didn't test this one case, and then then you go back to sleep. And the next morning, you will go and and make some changes. That's cool. If I get like 20 submissions from somebody, that'll be a little annoying because I'll have to go through. But no, I mean, it's more important that that you feel that you've submitted your best work, and so don't worry if you've already submitted once before the deadline, before it's due. We can do it again. A couple of notes, lots of notes. You can only submit Java files. I don't want your class files. I also don't want your POM, and that's like we talked about last week. When I build your project, I'll start with the grading script uses the archetype to create a brand new project, and then it explodes the jar file on top of your on top of the project created by the archetype, and that's how it uses your source code. So I'll be using basically the same POM that you are, but it also means because you don't submit it, you can't modify it. It enforces that your source code is in the right directory. So if you've done something like change the name of one of the directories so it doesn't correspond to your package name, it will the submit program will complain. Please only submit your source code. The program won't let you submit files that are like my files. So if you go and change abstract phone call, it won't let you submit that because that's my code. You can't change my code. Actually, I don't want you to change your. I don't want you to change my code. If you're changing my code, then something's wrong, right? The whole idea is that you're supposed to reuse my my code and subclass and do more things with it. Let's see here. Please make sure that all your code compiles before you submit it. So like do a Maven clean to blow away everything in the target directory and compile from scratch. We will not debug your code for you. There are 40 of you. That doesn't scale. Sean's a pretty intellectually curious guy, and so maybe he'll spend a little bit of time, but please send us code that at least compiles. Yep, something goes wrong, okay, we'll send you the output. But if it doesn't compile, that's like furrow-browed unhappy. If you ran out of time or whatever, there's missing functionality, just make a note of it in your comment so that we're not completely surprised and blown away by it. Please submit all of the files required for your project in one invocation of the submit program. It makes it easier for us, and also. But if you find you do miss a file or whatever, or in subsequent projects, you'll be using your phone call class again, and even if you haven't made any modifications to it, that's great. Send us it anyway. We're not going to keep track of your files from project to project. Just please send all the code. Again, it's okay to submit multiple times, but we're only going to grade your latest submission, and so don't make us do too much work, even though we've automated a lot of it over the years. Late policy we covered last time, and since, you sent an email, we know when it was submitted, so there's really no question about, you didn't get it. We know when we got it. And here again, if you're having problems doing troubleshooting or whatever, you can use verbose or SaveJar, but usually everything works pretty well. Okay. Any questions on those? No? Okay. So that is submitting. So I think that's everything that you need to do your projects. So you've seen the project assignment, you've archetype, Maven, all that good stuff, and you've seen how to document it, you've seen how to submit it. So, any questions? No? Okay. Finally, let's take a look at Project 2. So in Project 1, you wrote, or you are writing, sort of the fundamental application classes for your phone bill program, your phone bill and your phone call. In Project 2, you will persist phone bill and phone call information between invocations of your program by writing them out to a file. And so the goal of this project is to learn how to use Java's I/O facilities and to throw exceptions when things go wrong. So in addition to your phone bill and phone call classes, which I don't think we'll have to change. You won't have to change for this assignment. If you find something you want to change, you can, of course, feel free to do so. I want to add some more classes to your package. First one is called TextDumper. So TextDumper is a class that implements the phone bill dumper interface. That's my interface, your class. And what it does is it dumps the contents of a phone bill and all of its calls out to a text file. Now, this is a text file that is not meant to be human readable. It's a text file that's meant to be read by a machine. So it doesn't need to be pretty, it doesn't need to be well formatted. The file of the format is completely up to you. And so, you know, that's part of the assignment is writing it out to a text file. TextParser goes the other way. So it implements an interface called Phone Bill Parser, and what it does is that it reads the contents of a text file, and from it creates a phone bill with its phone call. So as described in the file, it will read it and turn it into the phone bill object.
Do we specify the format of the file that we're going to be reading from?
It should be the same file format. So it's the same format that the TextDumper uses. Did that answer your question? Yeah. Okay. Yes. And so you're not writing. Well, you could use XML. You don't have to use XML. You can use whatever you want. And the file is not meant to be portable between people's assignments. So I'm not going to take your TextDumper and try to use it with your TextParser. That's not supposed to work. If we did, we would use a standard format, but we're not for this project. This project is driven by a class called ProjectTo, which has a main method, and it does the following. It reads a phone bill, optionally reads a phone bill if the -text file option is present. It'll read the contents of a phone bill from the text file, provided text file. It'll create a new phone call based on the command line option. So remember in Project 1, it's like, this is kind of lame. I put all this phone call information in, and all I can do is print it out. Yes. Okay. Now you get to actually do something with it. So it'll be persistent between invocations of the program. So it'll take the information that's on the command line, create a phone call object, add it to the phone bill, and then if the -text file option is specified, it'll write it back out to the text file. So if you look at the command line interface for this program, it has the same arguments as it did in Project 1, the name of the customer, the phone numbers of the caller and the callee, and the start time and the end time. Still in the same, still 24-hour time. And it's got 3 options now. It still has -print and -readme, which have exactly the same behavior as it did in Project 1. And now it's also got this new -text file, and that's where to read and write the phone bill from. So if -text file is an option, which means that if it's not specified, it has exactly the same behavior as it did in Project 1. It's important to note that if the text file doesn't exist, so I say -text file, phonebill.txt, and if phonebill.txt doesn't exist, that's okay. What your program should do is create an empty phone bill, add that phone call to it, and then write it out to, well, basically create then that new file. Don't blow up. Right? Because otherwise, how do you bootstrap the process? You got to be able to create the file the first time. And so anyway, and then also note phone numbers, dates, times, all that stuff using the same format as in the previous assignment. So none of that changed. So I hope, as you're looking at the specification, you're sort of seeing, you're sort of thinking in your head, what parts of my code need to change? Where do I need to do things? Maybe understanding where we're going with Project 2 might help influence how you design and implement Project 1. Okay. Error handling, more graceful error messages and things like that. A couple things that your program should do. Error gracefully when there's something missing from the command line or the command line arguments and you got too much stuff on there. Formatted the date or time, not what you expect. If the text file is malformatted, so if you can't parse it, issue a nice error. Don't want to see null pointer exceptions. Don't want to see, number format exceptions escaping to the command line, things like that. And also, if the name of the customer on the command line doesn't match the one that's in the text file, right? So those are the kind of error conditions, some of the error conditions that you will you ought to be looking for. Any questions on your Project 2? It's due in 2 weeks. And remember, you've still got the cones to work on too. So if you haven't dug into Project 1 yet, you might want to, well, I mean, it's due next week. And so knowing that this stuff is starting to pile up, make sure to get that done sooner rather than later. Yeah?
Will you be checking for validity for times and dates? Like, what is 1305?
Right.
Without something to validate.
Right, and the question, for those of you on the recording, is are we, do we need to check validity of dates? There was a question about this, similar to this on the community, and what I said there is that the syntax of the date, yes, like I want a number to be a number. If you have, June 31st, I'm not going to call that an error. I sort of said, hey, whatever Java's date parsing stuff uses is probably a good way to check it. But the data that I use to test, all of the numeric dates are valid. Yeah, thank you. Okay. Any other questions on part? Yes.
Do you think we want to hold on to the string representation of it? Because I was thinking just ditching the string and just throwing it as the date objects.
So yeah, I mean, should we still use the string representation, or do you want to go to dates? You can go to dates at any time, and so then you can do it here, and that might help with the validation. Might help with the writing it to and from the text file. You don't have to. The next assignment in Project 3, that's when you'll have to go with dates. So if you want to get a jump start on that now, wouldn't hurt. Good question. Okay. 6:36. Let's watch a video, take a little break, and then come back. Okay. Cool. So okay, that's all the administrative review in class, and so that's project stuff, and everything to go do your project. And so while I encourage you to come back to class after break, you don't have to. So. But this is the fun part, right? This is where you actually get to see code and get an idea of what you'll be doing during class and the rest of the class. So, pair programming. So, I think I mentioned, yeah, we'll do this later. I think I mentioned extreme programming last time. And So in addition to test-driven development, where you're getting this really quick feedback on your code, many people have found pair programming, having two people work on the same problem together, to be very beneficial. I think some of the benefits that they cite are, well, you get two eyes on the problem. And even though there are two people and they're both sort of looking at the code, there are different roles. So there's one person who's actually at the keyboard and is typing, and really they're sort of like in the syntax of the code. And then the other person is the navigator, who is sort of thinking maybe not so much about what needs to be typed, but sort of like, what is the problem that we're trying to solve? What's the next test that we need to write? And are there places that we could refactor? And what this kind of focus does is it allows both of them to go faster than one could individually. So instead of having to either play both roles or switch back and forth sort of every 15 seconds, it allows you to focus on doing one thing for a little while. What are the other downsides? Well, sorry, one of the other upsides. Also, when you're done, you now have two people that are intimately familiar with the implementation of the code. And so that makes it easier to hand it off or to come back to it later. And also, when you have pair programming, you probably don't need to have other people review your code. You've got one set of eyes on it. It's probably good enough. Some of the downsides that people cite is that, well, you're working with people, right? And hopefully everybody showered that day, and brushed their teeth, and all those other sort of hygiene and grooming things that are important. Also, the jury's not really out in terms of whether or not it's more efficient. I think, there will some people that just like want to complain, well, someone else will slow me down, or, oh, you're paying two people to do the job of one person. I think there's some validity in that, but you're also getting a lot more learning, a second set of eyes, and while I don't know if there are lots of studies to back this up, I tend to think you end up with something that's higher quality when you have two people working on it, because you find the bugs sooner. It's easier to stay disciplined when you've got someone looking over your shoulder, or at least a partner there to support you. Let's put it that way. So anyway, one of the things that I like you guys to experiment with is pair programming. Next week we'll see mob programming also, which is sort of an expansion of it, here in class. So to give you a little preview of what we do next week, we'll be starting things called code katas, which are basically small little programming assignments, projects, to really get you to think about a problem and to explore the language and to do it with other people. Tonight, though, we'll watch a cheesy little video all about pair programming, and it is kind of cheesy. And it's kind of like the film. Oh wait, you guys know what film strips are, right? You're not that young. Okay, good. Right. It's kind of like, you know, the film strip that you used to watch in elementary school. You know, the boop boop, and they would change it anyway. That's what it's cheesy like that. And then Sean and I are going to be doing some pair programming. We're going to continue working on that student project. And actually, it doesn't need to be just me and Sean. If anyone else would like to come up and pair, you're more than welcome. So maybe after the break, someone will get inspired and come up and work with me. And then next week, we'll start doing it all as a class, leveraging this awesome classroom that we have for that. So, without further ado, let's watch a video about pair programming.
Hello and welcome to Fun with Pair Programming, an introduction to pair programming for students. If you're a student who is new to pair programming, you've come to the right place. This video will help provide valuable information to make you the best pair programmer you can possibly be in your classes and beyond. Pair programming refers to the practice whereby two programmers work side by side on one computer, collaborating on the same design, algorithm, code, or test. The pair is made up of a driver who actively types at the computer or records a design, and a navigator who watches the work of the driver and identifies problems, asks clarifying questions, and makes suggestions. Switch roles from time to time to share the work evenly and get the most out of your pair programming experience. You'll hear effective pairs constantly chatting as they jointly decide how to tackle the task at hand.
Well, actually, I don't even know where it's saving this stuff. So we create a new patient and it adds record. Oh,
right.
Probably in save data file. Mm-hmm. So it's going through, looks like a list of records.
Mm-hmm. So we probably, since we just added the height and weight, I don't know if that's actually getting written.
Yeah, probably not.
Okay.
So
why do so many thousands of students around the world prefer pair programming? Why don't we ask some to compare old-fashioned solo programming to this new and innovative system?
Wait, what was the order?
You would program by yourself, so you'd usually be just by yourself in a computer, maybe in a cube or at a single desk, and it's a very lonely type thing. It can be.
Well, it could be really frustrating. You'd sit there banging your head against a desk and trying to find, the missing bracket, or couldn't figure out why the logic in your program didn't quite work right. And with two people there, it's a lot easier to work those problems out a lot more quickly, so you're not frustrated all the time.
This is nothing new either. Most science labs take advantage of lab partners and small groups. Computer science is no different. You can learn a lot from working with other people. Students find it helps them get better scores on programming projects. Pair programming helps them learn, so they get better grades on exams as well. Mostly, students report that they enjoy getting to know the people in their classes better. This makes it much easier to interact when problems do arise, because you've got a class full of friends instead of strangers. Last, but certainly not least, students are much more likely to figure out solutions if they've got someone to brainstorm with, and this can lead to faster completion times and a better understanding of the subject matter. Students often find the whole experience much more enjoyable and less frustrating. Pair programming will also help you prepare for your career in computer science. In the professional world, people collaborate and pair program all the time, and as an expert, you'll already be ahead of the game. Have you ever spent most of your class time with your hand in the air, getting nowhere on a project while you wait for help from your professor or lab instructor? With pair programming, those days are history, and you'll find yourself having a lot more fun. Who knows? Maybe you'll even look forward to the alarm going off in the morning so you can get to class. Now that you know the basics, let's look at some simple do's and don'ts of pair programming. First, be sure to talk. Not a minute should go by when you're not communicating somehow. Don't say anything that might insult your partner. Even if you're only joking, he or she might take it personally. Don't forget to listen too. Both the driver and the navigator should be fully engaged in the project. So much so that the driver can pass the keyboard to the navigator at any time, and he or she will be ready for the switch with no questions asked. Periodically switch positions so you can gain experience in both roles. Switching helps prevent errors and stimulates conversation too. Be patient. Be prepared to explain yourself to your partner, and don't get frustrated if they don't understand it first. By explaining your work to your partner, you'll be helping yourself learn as well. Remember the ancient Chinese proverb, "To teach is to learn." And be sure to give the driver a little time to correct his or her own mistakes. After all, no one likes a backseat driver. Respect your partner. The golden rule is key here. Just remember to treat your partner with the same level of respect that you expect from him or her. It doesn't matter if they are from another culture, an introvert, an extrovert, a procrastinator, or the valedictorian. We are all here to accomplish one thing, and everyone has something to offer. Take breaks. You can get more done in 1 hour pair programming than in several hours by yourself. But this can take a toll on your brain. Don't forget to take a break every so often to keep yourself fresh and energetic. When you return, you'll likely see something you overlooked before. Be prepared. Be sure to do any preliminary work ahead of time, and don't be late for appointments with your partner. Their time is valuable, as is yours. Hygiene. Think about it. How would you feel if the person you were going to spend a couple of hours with smelled terrible? Take a shower, brush your teeth, bring some mints. You know the drill. Have fun! Working with someone else can be a lot more fun than working by yourself. You can share a laugh, relieve some tension, and have someone to celebrate with when you get that last test case to pass. Believe me, that's a great feeling. Now that we've gone through all the things you should do as a pair programmer, let's go through some of the things you should avoid when working with your partner. Don't be a keyboard hog, or think that just because your partner is a novice and you're more experienced, that they won't bring something to the table. Don't constantly tell other people what to do either. You don't want to be the only person in the class that no one wants to work with because you're too bossy. There is another side to that coin, so don't be intimidated. Some people are afraid that they don't know enough, but chances are your partner feels the same way, and you both know way more than you give yourself credit for. Trust me, it will all be fine. The primary goal of pairing is to work together towards the best possible solution, so don't be afraid to speak up if you disagree with your partner from time to time. Your partner may as well be working alone if you're not willing to speak up. If you're unhappy with your pair programming situation, for any reason, don't hesitate to talk to your professor or teaching aide. That's their job, and they will be happy to help you resolve whatever problem you may have. As you can see, there are many benefits to pair programming, but there are also a few speed bumps. Sometimes you'll find it difficult to find time in your schedules to meet, for example. But students all over the world agree that the benefits outweigh any drawbacks that they can find.
If there's two of you working on it, typically you're spending a lot less time working on it, so this is great for homework. Then also I would say that in general, your solution is going to be better.
So if you're working with somebody and their grade or their deadline matters to you, you're more likely to get your work done at an earlier time. Also with pair programming, you can typically have higher grades on assignments. There's higher quality code as well.
This concludes our journey through the exciting world of pair programming, but there's still much to learn. Take these tips with you into your next pair programming lab and join the growing number of pair programmers across the country, the world, and beyond.
Anyway, yep, cheesy, but I hope we got the point across. Let's take a 10-minute break. Come back here at 7 o'clock. I'll set up the station up here, and then you can see me and Sean do some pair programming.